Okay, now we're going to look at another possible method for solving these rational equations. This goes one step beyond the method that I just showed you. In this case, again, you're going to factor every denominator, put each factor equal to 0, and thus you will find your restricted values. Okay? Now, use the factors to find your lowest common denominator. Now multiply every term by the lowest common denominator, and thus you will eliminate all denominators. So this makes it easier to do this, okay? And then you solve the equation that is left. Now, let's look at a couple of these equations to use for this. Okay, here it is. 2 over 3x plus 1 equals 1 over x minus 6x over 3x plus 1. Okay, so first thing you're going to do is factor. Well, 3x plus 1 will not factor. X is already as simple as it gets, and 3x plus 1 doesn't factor. So we don't have anything to factor. But let's put these various ones equal to 0. So for your restricted values, you have 3x plus 1 equals 0, and x equals 0. Well, that one's already done. Subtract 1 from both sides, and you get 3x is equal to negative 1 divided by 3. So we have x is equal to negative 1/3. So your restricted values will be x cannot equal negative 1/3 or 0. So now let's build our lowest common denominator. First term has 3x plus 1 in the denominator. So that will be the first one. X is not in this because this is all one thing. So we have to put it here too. Now our next one has 3x plus 1, so we're finished. So our lowest common denominator is x times 3x plus 1. Now we're going to multiply every term by that. And it's at the numerator level. So you have x times 3x plus 1 times 2 over 3x plus 1. And now this is equal to x times 3x plus 1 times 1 over x minus x times 3x plus 1 times 6x over 3x plus 1. Okay? Now, 3x plus 1 cancels with 3x plus 1. And you're left with x times 2, which gives you 2x equals. X cancels with my x, leaving me 1 times 3x plus 1. Now this one, 3x plus 1 cancels with 3x plus 1, and I have a negative x times 6x, which gives me minus 6x squared. So as you can see, we're going to have a squared term on this one, and we're going to end up having to factor when we're done here. So we're going to add that 6x squared plus 6x squared to both sides. And we're going to subtract 3x and subtract 1. So this is going to be minus 3x plus 6x squared, and then minus 1. So this is going to give me 6x squared. 2x minus 3x is a minus x. Minus 1 is equal to 0. And I put it equal to 0 because I have a squared here, which means we're going to have to factor. So 6 factors into 2 times 3. So you have 2x times 3x. I'm going to have the larger one has to be negative because this is negative 1 times 1. So 3x is going to be my negative, so negative 1 here plus 1 here equal to 0. Negative 3x plus 2x gives you your negative x. Now, each factor has to be put equal to 0. 2x minus 1 equals 0, and 3x plus 1 is equal to 0. Well, let's do this one first. So 3x is equal to negative 1 divided by 3, and x is equal to a negative 1/3. And what do you see? Negative 1/3 is restricted, isn't it? Therefore, that is not a valid answer. Now let's do this one. Plus 1 gives you 2x is equal to 1 divided by 2. So x is equal to 1/2. Yes, that is not restricted. So x is equal to 1/2 is my only solution for that problem. And as you move on up into more and more advanced mathematics, the ability to eliminate denominators by multiplying by your common denominator can become a very valid and very useful skill to have. So we're going to do one more problem. And it's often easier in the long run to do this. It's just a little more complex as you're learning how to do it. So we're going to do one more problem this way. Okay, so if we look at this again, x plus 3 is already simplified. It's as factored as it can be. X minus 5 is as factored as it can be. This one is not, so we need to factor it. X times x. 15 is a 3 times 5, okay? Negative 2 says that my larger number is going to be negative. So therefore we have an x minus 5 times an x plus 3. Now, let's look x plus, for your restricted values, you have x plus 3 equals 0 and x minus 5 equal to 0. Solving this, we get x is equal to negative 3 and x is equal to 5. Thus, your restricted values are x cannot equal negative 3 and 5. Okay? Now, looking at our lowest common denominator. Looking at our first term, we have x plus 3. Look at our second term, we have x minus 5. And since that's different from my x plus 3, I have to write it down. X minus 5, already there. X plus 3, already there. So your lowest common denominator is x plus 3 times x minus 5. Now we're going to multiply every term by that. So x plus 3 times x minus 5 times 6 over x plus 3 plus negative x plus 3 times x minus 5 times negative 7 over x minus 5 equals x plus 3 times x minus 5, and these are in the numerator, times negative 48 over x minus 5 times x plus 3. Okay? Now, starting back over here, x plus 3 cancels with x plus 3, leaving 6 times x minus 5. Okay? X minus 5 cancels with x minus 5, negative 7 times x plus 3 equals x plus 3, x plus 3, x minus 5, x minus 5, negative 48. Okay? Now we're going to have to distribute, giving me 6x minus 30, negative 7x, negative 7 times 3 is minus 21, equal to a negative 48. Combining like terms, 6x minus 7x is a negative x. Minus 30 minus 21 gives you minus 51, equals to a negative 48. Add 51 to both sides, and I end up with a negative x is equal to a positive 3. Divide by negative 1. So x is equal to a negative 3. Now let's check. Is that negative 3 a restricted value? Yes, it is. Therefore, this is not a valid answer. This problem has no solution. Just happen to choose one that came out that way. You just never know. You have to watch for it, okay? So this, again, I think is an easier way if you can get it down. It's just that this first process here can be more complex, and some of you may struggle with it. So you have two different ways to do these, and enjoy them.